Good afternoon, everyone. We are Group 8 here to present on the topic low energy consumption for home and offices using Bluetooth low energy based networks having improved privacy and security. I'm Smriti and I'll be introducing the topic to you. Nowadays, it is becoming important to monitor and control applications for energy harvesting using smart wireless devices. Using these networks, it is easy to keep track of energy consumption of appliances and high power rating loads in peak hours. The goal of the paper is to build a cost effective and minimal energy consumption application using the Bluetooth low energy technology. Now, let's look at the functionalities of Bluetooth and BLE. There are two major functionalities of Bluetooth, namely generic access profile and the generic attribute profile. The generic access profile or the GAP layer in Bluetooth Low Energy Stack Protocol is responsible for connection functionality. It performs two major roles, the peripheral role and the central role. As a peripheral role, it advertises and is open to connect to other devices having the central role. In the central role, it scans for advertisements and initiates connections to other devices having a peripheral role. It is also accountable for various security features such as bonding, pairing, and device authentication. The next one is the generic attribute profile or the GATT. The GATT layer of the Bluetooth Low Energy Protocol stack is used by the application for data communication between two connected devices. Data is passed and stored in the form of characteristics, which are stored in memory on the Bluetooth Low Energy device. From a GATT standpoint, two connected devices are in either one of these two roles, a GATT server or a GATT client. A GATT server is the device containing the characteristic database that is being read or written by a GATT client. A GATT client is that device that is reading or writing data from or to the GATT server. A peripheral can either be a GATT client or a GATT server, and a central can be either a GATT client or a GATT server. Whereas a peripheral can also act as both a GATT client and a GATT server. Now we'll move on to the next slide.
Hello everyone, I'm Sindhu Bhavna and today I'm going to speak about Bluetooth Low Energy and how does it work and what is the architecture we are using in this report. So coming to Bluetooth Low Energy, Bluetooth Low Energy is a low power wireless communication technology that can be used over a short range to enable smart devices to communicate. And Bluetooth Low Energy has a wide range of possibilities and is implemented in a broad set of fields like health, fitness, security, home automation, and IoT, and many other things. In this paper, we are going to talk about how Bluetooth Low Energy is used in home automation. So, coming to Bluetooth Low Energy in home automation, here in the architecture, we have two parts. One is Bluetooth based energy monitoring method, and the other is Bluetooth enabled energy measurement device. Coming to the monitoring method, the Bluetooth low energy based system has two components. One is communication component, and the other is measurement component. In the measurement component, it measures the accumulated energy consumption and it stores the measured data in its memory queue periodically. And the Bluetooth communication component, it composes of the energy data packet from that stored data and its device ID, and it broadcasts that packet periodically in accordance with the advertising interval. So moving on to the next slide. The next slide talks about Bluetooth low energy enabled energy measurement device. In this energy measurement device, the microcontroller on the device, it calculates the accumulated energy consumption from the measured voltage and current, uh, and uh, and and this is what happens in the Bluetooth based low energy home automation model. So moving on to the next slide.
Okay, thank you, Sindhu. So my name is Aditya. I will explain how the smart home system is configured and how it will work with the Bluetooth low energy devices. So over here we have three modules. First is smart meter, then we have energy management unit, and third is smart home appliances. So all the home appliances will have smart plugs, so we can control them automatically without human interruption. So this system will consist of various energy sources ranging from storage devices, which is EMU, then energy sources, the electrical appliances, and control unit, and communication tools. For communication, we are going to use home wireless sensor home area network, and we will be using Bluetooth low energy to connect all the devices together. So these devices can be active in various time periods. Like a refrigerator can be active for 25 minutes within a 50 minutes time period, due to frequent operation and air condition, depending upon the operation also. It also depends upon the hours on the weekends. So, for example, in the weekdays it is less used, and for weekends it is most used device. So yeah, so next we can come up with the scheme which aims to reduce the electricity cost based upon the usage of these appliances. So for example, any device is being used by all the consumers, which will put a load on high voltage power line. So what we want to do is to provide a customer with a range of rates of the electricity based upon the appliances. So, for example, in peak hours of the refrigerator, if the consumer use the refrigerator, he will have to pay more for the electricity. If he will use the refrigerator in off peak hours, he will pay less for the electricity. So we can come up with all those plans using the algorithm, which will be covered in the next slides. For the smart home system with EMU, Energy Management Unit will provide the real-time rates to the user. So this Energy Management Unit will gather all the data from the usage of the appliances. It will provide the data to the high voltage power line, and they will come up with the rates based upon what kind of a usage has been you know uh, given by the EMU. So for example, we have set up a wireless sensor home area network over here, and EMU will collect all the data using smart plugs, and it will keep a record in the cloud. And after the data analysis, it will come up with the algorithm to give a real-time rates to the consumer. So we will look into in depth of this algorithm in coming slides. Uh, for the next slide is smart plug system.
Thank you, Aditya. This is Pooja. We will go through architecture and design of smart energy monitoring system. Over the years, the traditional electric meters is being used, which is the electromagnetic induction watt meter. This robust technical design is in use for over a century, but it is only capable of measuring the amount of energy the user consumed. And the main disadvantage of this design is someone from the electrical company or the consumer himself has to read the meter manually, which implies cost and administration effort. Due to these disadvantages, smart energy monitoring system is getting popular these days to read the data from the sensor and control many residential activities to save cost and energy. The smart energy monitoring system consists of three main parts: Bluetooth energy smart plug, Android application, and open cloud server. The first one is BLE smart plugs, which performs energy measurement and control. It consists of four main components: Hall effect sensor, AC/DC power supply, microcontroller with radio, and relay. The Hall effect sensor is used to convert current to voltage, and it uses Hall effect to measure current that can be either non-contacting or inline. The high voltage AC input is electrically isolated from the low voltage output inside the inline Hall effect sensor. Next one is Android. Android 4.3 introduced a built-in platform support for Bluetooth Low Energy and provides API that apps can use to discover, connect, read, and write characteristics. Android application provides all the features that Smart Plug offers, but it gives in a user-friendly way to consumers. These application shows a list of plugs that are accessible to users or connected to these applications. And for each plugs, it gives very detailed numbers and buttons to control and monitor over the electricity usage by the residential activities. The third part is Open Cloud Server. In this paper, we are using ThinkSpeak, which is a web-based open API IoT source information platform that stores sensor data of various IoT applications and plot the data output in graphical form at the web level. It allows the user to display graphically the sensor data gathered in a web interface using channels. The user can configure a public or private access to these channels. Moving on to the next slide.
Yeah. For the next slide, we will be discussing wireless sensor home area network. As discussed earlier, this will be used in smart home system. WSN is appropriate for implementing such in-home application due to its scalability for attaching new devices and appliances to system very easily. Here we are using Bluetooth Low Energy to transfer all the data and connect all the devices. As this network is based upon Bluetooth Low Energy, it will have the advantages like low power consumption, sufficient range of operation, and it will also have the compatibility between multiple types of devices. Yeah. Uh, and next is Bluetooth HEMS algorithm. So as stated earlier, this algorithm will be used for providing the real-time rates for any given appliances at any given time. So this algorithm plan convenient start time for applications based upon cost-effective operation. So to reduce the load on the main power line, we will come up with the cost so consumer can decide whether he want to use appliances or not. If at the peak time the rate of the refrigerator cost is very high, then some of the customer will not prefer to use that and will use it in off peak hours. So that will put off load from the main power line. This takes current electricity price of the particular use into consideration and calculate which appliances should be used at a given time for reducing total electric cost for a smart house. So this will also provide advantage for consumer to lower their electricity bill. When appliances shifted from peak to non-peak hours, it will be notified to the consumer to use the devices. So it doesn't mean that customer will not be able to use the device in peak hours, but we will provide them with the recommendation. Okay, so you want to use this device in off-peak hours to reduce the electricity bill. Next is device authentication in Bluetooth.
Right. Thank you, Aditya. As we all know, security is an important aspect while devising a system. Here we will be focusing on device authentication in Bluetooth. There are two main steps involved in authentication. The first one is pairing. Pairing is the process which involves virtual key exchange for linking security and encryption. Initially, it requires entering a passkey for establishing a secure connection. Once the passkey has been entered and the identity information stored, there is not required for a connection re-establishment. At any given point of time, there can be a maximum of 4 bonded devices. The next step in the process is whitelisting. Whitelisting involves uh, is a process that allows the system to filter out unauthorized devices. Only Bluetooth devices added to the whitelist will be given scanning and connection privileges. In general, a BLE component is dually programmed as a peripheral and a server. Now, coming on to the conclusion.
So from this paper, we have learned many things regarding Bluetooth Low Energy model, regarding the architecture and its functionalities. So now let's draw the outcomes that we have learned from this report. So this Bluetooth-based low energy model monitoring method, has broadcasting mode and energy consumption device, which measures the consumed energy, and it aggregates the data, and this data is stored in the measurement device, and it is further transferred to the mobile device in a Bluetooth low energy based connectionless manner. So the mobile app aggregates the energy consumption data of the multiple home appliances simultaneously, and it will be given to the user. So this is what happens in the Bluetooth low energy based home automation model. Thank you.
Yeah. Okay. Thank you, Sindhu, for the conclusion. I just wanted to add some points over here. Continue to this conclusion. So yeah, we started from the smart home system, and then we came to the Bluetooth algorithm, which will take all the data from the smart plug and EMU. It will give the data to the main power line, and they will provide the rate based upon the usage of any appliances. so to reduce load on the main power system, and it will be also beneficial for our consumers to use these appliances in off peak hours, so they will be paying less for any appliances at given point of time. So yeah, so all these models work very well with this smart home system, considering the uh, all the smart devices with all smart plugs, and then Android application. It will take all the data and upload it to the cloud. So we will have all kind of algorithm and the data together to provide the best price in real time. Yeah. So that's it from my side. Thank you guys for your contribution, and thank you guys for listening to our paper presentation. Yeah. Thank you.